This is Mr. Martin. This is a video on section 7.1, problem number 19. I'm not going to do a very formal proof here, but I'll just kind of give you the ideas, and hopefully that will give you enough to understand the solution. So we want to prove that the midpoint of the hypotenuse of a right triangle is equidistant from all three sides. So we need a right triangle. So I'm going to call it triangle ABC. And we also know that we have a midpoint, so I'm going to call that D. And I need a distance here, so I'm going to draw that segment in here also. So we're given triangle ABC is a right triangle, and we need to kind of specify what the right angle is. So angle ABC is a right, that should be triangle, angle, and we also know that D is a midpoint. And then we want to prove that DA is congruent to DC, which is congruent to DB. So this tells us this congruency statement, remember equidistance in a proof is shown by congruent segments. So if DA is congruent to DC is congruent to DB, then I know all these are congruent. So basically what we want to do here is we want to take this right triangle and we want to change it or add to it so that we have a rectangle. So I'm going to draw in a segment here that's parallel to BC, and there's actually a postulate that allows us to do that, and I'm going to put a point here. I'll call that E, and then I'm going to do the same thing over here at C. I'm going to draw in a segment CE that's parallel to AB. So now I've got I have a quadrilateral here, ABCE, and I've got both pair of opposite sides are parallel, and since I know that this angle is a right angle here, I have a parallelogram with one right angle, which makes this a rectangle. So that's going to be the key here, is that when I draw in these two sides that are parallel to the legs of the right triangle, I get a rectangle. And then if I continue on and draw the rest of that diagonal, now I have the two diagonals of the rectangle. And one of the properties of a rectangle is we know that the diagonals are congruent. So you'll have to write some stuff to say that you're drawing in AE parallel to BC and drawing in EC parallel to AB, and then some stuff proving that it's a rectangle. And then once you get that it's a rectangle, and you have these two diagonals, we can say that AC is congruent to BE because diagonals of a rectangle are congruent. And we also know that the diagonals of a parallelogram bisect each other. Therefore, the diagonals of a rectangle, since a rectangle is a special parallelogram, we know that these diagonals bisect each other. So basically we know that since diagonals of a rectangle bisect each other, we know that AD is congruent to CD and BD is congruent to ED. And by the multiplication property, actually by the division property, since AC and BE are congruent, then they're smaller pieces. So by division, I know that actually all these pieces are congruent. AD is congruent to CD, is congruent to BD, is congruent to ED. Okay, so draw on the parallel sides, make it a rectangle because it's a parallelogram with one right angle. You know the diagonals of a rectangle are congruent. You know the diagonals of a parallelogram and a rectangle's a parallelogram bisect each other, so all the little pieces have to be congruent by the division property. So there you have it.